chapter that's all about algebraic fractions, which is a huge deal. In higher math, you have to know how to work with these things. You should come to my Calculus 2 class sometime just for fun and see the problems we do that take 2 pages, and man, it's just algebra everywhere. That's the stuff we're learning in here, but it's a part of the bigger problem. And if they don't know how to do it, they're not going to do very well. Okay, so what we're going to look at in here is rational expressions just kind of look like this. This one has got a mistake on it. I think that's supposed to be like x minus 9. You're never going to have x equals 9 there. So what they are is they're algebraic fractions, okay? The numerator and denominator have some kind of algebraic expression in those, okay? And they usually kind of look like factoring problems. They have polynomials. These individual things are called polynomials. So what a rational function is just a ratio of what we call polynomials, and just think of polynomials as the factoring kind of problems we've been working on. That's good enough for now, okay? So what we're going to do is we're going to learn how to algebraically simplify. We're reducing algebraic fractions, okay, like this, okay? So there's several ways you can do this. Now I'm just going to look at one way to start this one right here, okay? You're more than welcome to do this problem in your head. You've already done this semester, by the way. So one way I'm going to show you to do this is we can actually factor 15k to the third. If you factor it, 15 is 3 times 5, and k to the third is k times k times k. So I'm going to have you write it out that way just on this problem as 3 times 5 times k times k times k. And then the way you factor 5k is you just do 5 times k. Okay, you really don't have to do this because you can do this in your head anyway. Now what happens? 5 over 5 is 1, isn't it? K over k is 1. What are you left with? 3k to the second, exactly. So now you put it back together and you have 3k to the second. Everything canceled in the denominator, so technically you have that over 1, but you never have to put something over 1. That's it. Okay? The idea is you want to factor and cancel. Factor and reduce out common factors. Okay, I love the next one. If I gave you a quiz and put 20 problems on this, everybody would hopefully make 100. What happens on this? Y minus 3 cancels, right? I've already factored it for you. It's already in a factored form. So what we have left over is y plus 8 over y plus 9. Well, see, that's kind of your goal on the more complex problems, is factor and cancel. The value of y minus 3 over y minus 3 is 1. Okay? So you just write down what you're left with. Okay? Now, you might want to make yourself a note. I see students do this all the time. It's a part of the learning process. You cannot cross that out and get 8/9. The reason you can't is because of those plus signs. Okay? If it was written as y times 8 over y times 9, then yes, that's okay to get 8/9. We've looked at that before, so you can't cross out within plus and minus signs. You can only cross out the big factor. Does that make sense? Okay. Now, the next one. You might want to write yourself a note on this. I think it would be helpful, and maybe put like 3 or 4 explanation points. Okay? Because I try very hard in this class to get students out of that bad habit so they don't mess with this in college algebra. So what I see students do all the time is they'll cross the x's out. No, you cannot. Then they'll go through and reduce that maybe to 4, or what would that be? 4/5. Anyway, don't do that. Okay? You cannot do that because of the plus signs. The only way you can simplify an algebraic fraction is to factor, then remove factors. In that order. You have to. Okay? So no, you cannot cross stuff out. So what you have to do is apply what we've been working on. So look at the numerator. What's the common factor between 16 and 20? Give me the biggest one. Not 2, but what? 4. Good. So take a 4 out. So 4 times 4x is going to give you 16, and 4 times 5 is going to give you 20. So you start that way. All right, look at the bottom. What do you take out of a 20 and a 25? A 5, right. Okay, so we do that, and then 5 times 4x, and then 5 times 5, like that. That's the factoring, all right? Now what? Now remove the thing that's the same. Now you can. The reason you can cross out now, because see, that's a times. 4 times something. That's 5 times something. You can cross that out. The answer to this problem is 4/5. Okay? You must factor, then cancel in that order. Okay? You have to. Okay? The factors turned out to be the same. So you have to get your factoring correct, then you can cross things out. Yes?
So I missed that last step on number 3, the 8 ninths.
For right here?
Number 3, so the 8 ninths.
Oh, okay. All I did was it was already factored.
Yeah,
So what was left over after I crossed out?
Oh, so that's just the answer.
Y plus 8, Y plus 9. See, after you cancel, whatever's left is what you have.
So that's the answer?
That's it. Okay, that's it. You cannot cross those Y's out. You are done when you get to that stage. Okay? It's real simple. Factor, then remove common factors, then whatever's left is your answer. Okay? All right. So let's look at this next one. Okay? Look at the numerator. You're totally in factoring mode now. How do you factor that numerator? You take an A out, right? Okay? You take an A out. Okay? So I'm going to go ahead and take the A out of the numerator. When I do that, and it's got lots of common factors, so you'd have A times A is A squared, and A times 6 is that, right? Now, the denominator's already factored, isn't it? It's already got 2 parentheses, it's already factored. We like it. We don't multiply it out, we like it. Okay? All right, so there's your factoring. Now what? Cancel out. I like to call that removing a factor of 1. Okay, canceling, that whole thing's 1. Anything divided by itself is 1. Now what's left? That's your answer. Once you've canceled, you are done. So A over A plus 9, do not go any further, and do not cancel those A's. Okay? And kind of be careful about how you write your 9s and your A's. Okay? That's your answer. Factor, remove common factors, then you're done. All right, we solid? Okay? If you got your factoring down, you will be solid on this. Okay? Okay, now let's go to the next thing. So as we do this is, again, you're going to start seeing how good you are with factoring, because everything's mixed up. What kind of factoring problem is A squared minus 36? Difference 2 squares, right? 36 is what? 6 times 6. A squared is what? A times A. So factor it. You got to be solid on how to do that. So we're going to have A times A, 6 times 6. How do the signs go? Plus minus. That's how you factor a difference of 2 squares. Okay? Now the bottom is a trinomial. Okay, so when we do this trinomial, we're going to draw 2 parentheses. Your first term is A squared, so that's going to be A times A. And your last term is 12. So what do you want me to use for the 12? 6 and 2, right? 6 times 2 is 12, and 6 and 2 add up to 8, right? Okay, so what you're going to have there, doesn't matter which order, 6 and 2. And again, you want the 6A and the 2A to add up to 8. So that just means they're both positive. Okay, so what happens? Do you see something that's the same? Okay, and it has to be something on top and bottom. Sometimes I see students cancel 2 things if they're both on the bottom. No, top, bottom. I just take out 1. That thing right there is really a fancy number 1. So the answer to the problem is whatever you're left with. So that's going to be A minus 6 over A plus 2, problem done. Okay? Good? Okay, if you've got your factoring down, you won't have much trouble doing these, I don't think. Okay, everybody with me? Okay, let's move to one more of these, and I'll let you work a few of these. And if you get this down, there's a few little special situations we'll look at. So again, this one is just the trinomial. So you want to factor the numerator, and you want to factor the denominator. Okay, so let's go to the numerator. Okay, we're going to have y and y. Okay, what do you want me to use for the 16? 8 and 2, good. 8 times 2 is 16, and 8 and 2 adds up to 10. Okay, you want to start doing that as much in your head as you can. That's how the factoring goes. Okay, now we want to go to the bottom. Okay, the first term's y, that's the easy part. Okay, what do you want me to use for 24? What? 8 and 3, good. 8 times 3. 8 and 3 also add up to 11, right? So you're going to have 8 there, 3 there, with 2 plus signs. Okay, that's the trinomials we've already learned how to do. Notice what happens. If those go away, whatever you're left with is the answer. Don't go any further. Never, ever go any further. Because if you factor correctly, after you cancel that out, then you're done. Okay, that's how it goes. Okay? All right, so I'm going to give you a little time to work out. We're going to start with number 8 and just go down the bottom of the page to number 12 and do those. Okay? Number 8 you can do in your head, but I would like you to write it out the way I did. I would really like you to do that just as we're learning this. But ultimately, you can do that in your head. And be careful. Be sure that you take out the biggest common factor, because if you...
So that is correct.
What's that?
Sorry.
Are you okay?
Yeah, I just realized I got it right.
Oh, okay. All right. Okay. Let's see. Let's go ahead and get these done, and then and just kind of finish up here. So now you can do this one in your head. What I'm going to do is just write this as 4 times 5 for the 20, k times k over 5 times k. If you can't do it in your head, then just do that. So the answer I think we all got on that was 4k to the second. Okay, like that. All right. Now, you want to get out of having to write that out. The way you want to look at this is if you had something like k to the 10th over k to the 4th. I mean, all this means is this. I mean, which part of the fraction has more k's? The top does, and how many more does it have? 6. So that's k to the 6th. You're subtracting the exponents, but think about the reason why is because if you wrote it out, 4 of them would cancel, leaving you 6. That's why that works out. This one was real interesting. A lot of you, I think almost everybody got the right answer, but almost every one of you did not take out the biggest factor. Okay, the biggest factor between 16 and 24 is not 4. That's what most of you did. It is actually 8. 8 goes into 16 twice. 8 goes into 24 3 times. 4 is not the biggest, but although if you took a 4 out, you can still get the right answer because you'd have to do something towards a little different anyway. So the way I'm going to do this, I'm going to take an 8 out, and that would leave me 2x plus 3 there. I'm going to take a 10 out of the bottom. Okay, 10 is the biggest number that goes into 20 and 30. So if I do that, I would have 2x plus 3 like that. Okay, hardly anybody did that, but almost everybody got the right answer. Okay, you want to get in the habit of doing the biggest factor. Okay, now what you're left with is 8 tenths. Then when I was walking around, a lot of you didn't reduce that. So what does that reduce to? 4/5. So the answer is 4 over 5. You didn't have to do the problem that way, but that's probably the best way to do it, is make sure that you're in the habit of taking the biggest factor out. Okay, now the next one, what we're going to have on this is the numerator does not factor, so we leave that alone. The denominator goes like this. Okay, the first term I'm going to use 3x and 5x. And then I'm going to use 2 and 4 like this. So I'll put the 2 there and the 4 there. Okay, if you look at that, see that's a 10, that's a 12. The way you make 10 and 12 add up to 22 is to do that, right? So if you factored correctly, you got that. Now here's what most of you did. You gave me the answer 5x plus 4. No. There is something left on top, right? There is a 1 there. I see students do that all the time, okay? When you cancel something out, it doesn't just magically disappear. It's a 1. So the answer is 1 over 5x plus 4. So make that correction if you didn't do that. Okay, everybody got that? Okay, if it starts a fraction, it's going to end up a fraction. Okay, now the next two, let me just kind of quickly put up the factoring on here. I'm kind of running out of time, so I'm going to go y and y, 7 and 5. And then I'd have a plus minus. And then the bottom, you should have y and y. And then for a 40, let's see, what did you use? 8 and 5?
Yeah.
Okay, with plus and minus. Now, I don't have time to go over the details of factoring, but that's what you would have. Then this one cancels out. And then after that, you end up with the answer y plus 7 over y plus 8. Okay, like that. Okay? Does that look good? If you got your factoring down, then you won't have much trouble doing these. Okay, the last one, the numerator is a difference of two squares. So the numerator is a and a, 5 and 5, with a plus and minus. Okay, that's the difference of two squares, so you factor that way. The denominator, you should have a, and 4 times 5 is 20, and then 2 plus signs like that. Okay, now your factors can be backwards. Doesn't matter. What matters is those two things cancel, and then your final answer to the problem is going to be a minus 5 over a plus 4, like that. Okay? All right. So the key thing is get your factoring under control, and then you'll be able to do this pretty effectively on this section then, okay? I'll leave this up here for a second, too, if you need to get that copied.
I got them all right.
Yeah, me too. I got a 1 over the 5x.
I did the same thing.
Yeah.
I got the X, but I got the X plus 5.
Yeah.
Whatever it was. It's just like, yeah, okay.
It's like, oh yeah. But
This is no good when I'm actually getting it right. So.
it just has like a little bit of fraction phobia. I see fractions and I like it.
It's going away now. Isn't it?
Get rid of that fraction phobia.
I-
Fractions are your friend.
Decimals are what get
If I
me.
could remember how to like do them most of the time, it would help.
I just hate looking at decimals. I'm like,
Decimals are.
I can do it.
I prefer fractions over decimals.
I agree. I agree.
A lot of students don't. A lot of students was, I like decimals. No. The problem with decimals is sometimes they repeat forever.
Yeah.
And so then you have to like round them, and then it gives you round.
Then you're not going to get an exact answer. Fractions are exact.
That's true.
And I'm in computer science, so we just precision's a big deal.
Precision is a big
And it's
deal,
just
right?
like,
Right.
Thank you, sir.
Yep.
What? Yeah, it's like everyone makes you the doses correct. I'm like the old people. They're doing something like that, man.
Why are you doing
About the absences, is there anything I can do about that, or because Hal is in here every day, but I just
Well, the only thing I could do with you is I will check the 025 and see on that. And when we get over there, I'll pull up my computer and we'll look at the 025. Maybe you've been signing for 025
Oh yeah, I see.
because I kind of walk around a little bit more in there. So you're in the back of the class, and if I'll just match it up with whatever you have in 025. Okay, and I'll take one off because that's kind of my policy. And from now on, be sure you sign. Okay, you got to do that. Okay.
Sure.
All right. Oh man, you mean I didn't?